Let's do a little bit more with the chain rule. So we're going to find a few more derivatives. As a reminder, the chain rule is the derivative of the outside times the derivative of the inside. So we got the derivative of the outside function times the derivative of the inside function. So just as a reminder, that's what the chain rule is. So let's go ahead and take this one. Again, I like to figure out what is my inside function and what's my outside function. My inside function is whatever's inside. It's t cubed minus 3t squared plus 4 is inside, and it's inside something to the 500th power. So my derivative here would be 500 something to the 499th power. That's the derivative of my outside function. My derivative of my inside function would be 3t squared minus 3 times 2 is 6t, and then the derivative of 4 is 0. Again, that's the derivative of my inside function. This is derivative of my outside function. The last thing to do is put my inside function back in. It was t cubed minus 3t squared plus 4. This is why this is called the chain rule, by the way, because here is your derivative of your outside function, and then you chain to that the derivative of the inside. Let's do another one. Let's look at this one. Again, I don't like having square roots and things in the bottom. So I'm going to rewrite this. This would be 5x squared plus 3x plus 2 to the negative 1/2 power. So again, I'm not going to write them down this time, but I think you can see your outside function is something to the negative 1/2. So it's negative 1/2 something to the negative 3/2. Then times the derivative of the inside. The derivative of the inside would be 5 times 2, which is 10x, plus the derivative of 3x is 3, the derivative of 2 is 0. And then the last thing is just put back in what goes inside this parenthesis. And there's your derivative. You could have also left it and done it as a quotient rule, but it's a little bit easier to do it this way. We're going to go ahead and do this one. Again, what I probably would do first before I do anything is rewrite this as x minus 2 to the 4th and x squared plus 3x to the 4th. So that I can actually think of them as two separate terms. Then when I go to find the derivative, there are two ways to do this problem. I'm going to show you one way and I'll show you the other way. I take the derivative of the top if I'm using the quotient rule because I have a division. Derivative of the top is 4 times whatever to the 3rd times the derivative of the whatever. So I'm using the chain rule on the top. So the derivative of the top is a chain rule problem. The whatever was x minus 2 times the bottom, which was x squared plus 3x to the 4th. Then I'm going to subtract from that the top times the derivative of the bottom. And again, the bottom is also a chain rule. So it's the derivative of the outside, which is 4 times something cubed, times the derivative of the inside, which would be 2x plus 3. And my something is x squared plus 3x. And then the whole thing is over top of the bottom squared. So x squared plus 3x to the 4th to the 2nd. So now let's see if we can do something with this to make it look a little bit nicer. I notice I have an x minus 2 cubed in this term. I'm going to have an x minus 2 to the 4th in this one. We always take out the lowest power. I also notice I have a 4 in both, so we can take out a 4. X minus 2, the lowest power will be to the 3rd. I notice I have an x squared minus 3x to the 4th in this one. And this one's going to have an x squared minus plus 3x to the 3rd. So again, we always take out the lowest power. So it's going to be to the 3rd. So we took a 4, x minus 2 cubed. Of course, 1 is just times 1 is just anything. And then I took out 3 of these. Therefore, there's going to be 1 left. Oops, don't close that yet. And then I'm going to subtract. I took out x minus 2, but I only took out 3 of them, so there's going to be 1 left. I took out the 4, took an x squared plus 3x to the 3rd, took out all 3 of them, so they're all gone, but I still have this 2x plus 3. all over the bottom squared. And so I'm going to have x squared plus 3x. And remember what we do here is we multiply them, so to the 8th. But then I notice I have an x squared plus 3x to the 8th down here and 3 of them up here, so we can cancel. So these 3 will cancel and leave me 5 here. Go ahead and multiply this other one out. I would not multiply out the bottom, but we get 4 times x minus 2 cubed, x squared plus 3x minus, we're going to have 2x squared minus 3x plus 4x plus 6. Because I have 2x squared to the minus sign. I have 3x positive, that gives me minus 3x, minus 4x, but now the minus changes to a plus, and minus 6, but the minus changes it to a plus. All over x squared plus 3x to the 5th. And then I've got 4 times x minus 2 cubed. And then one of my x squareds cancels. I got a minus x squared. 3x minus 3x is canceled. I have a plus 4x plus 6 all over x squared plus 3x to the 6th. You could see if this factors, factor out the -1 and then see if what you have left factors. It doesn't in this case, so we're done. That's one way to do the problem. Another way to do the problem is to actually, again, separate it like this, but then bring this one up to the top to make it a negative exponent. It took my quotient rule and made it into a product rule. So then when I'm going to do this, I now use the product rule. The product rule is the derivative of the first, which is 4 times x minus 2 to the 3rd, times the derivative of the inside. The derivative of the inside is 1, times the second, then plus the first, times the derivative of the second. Now I'm bringing a minus 4 down, gives me x squared plus 3x to the minus 5. And then I take the derivative of the inside, which is going to be 2x plus 3. So what I notice again is I've got an x minus 2 in both terms. So I can pull that out. Always take out the lowest power. So the lowest power is 3. I notice I had a 4 in both terms. So I can pull the 4 out. I notice I have an x squared plus 3x. I'm going to pull that out. And again, I always take out the lowest power. But between -5 and -4, the lowest power is -5. So that's a smaller number. So in this first one, all that's gone. If I take out 5 of these, I'm going to have 1 left. So I'm going to have an x squared plus 3x left. I took out 3 of these, so I'm going to have 1 left. And I took out all of these, and I took out the 4, and I'm going to have that minus sign times 2x plus 3. And I ran out of space. So I'm going to have a 2x plus 3. And then I can go ahead and multiply most of the stuff out. This stuff I'm not going to multiply out. I'm going to leave it exactly where it was. This is going to give me x squared plus 3x. This is going to give me a minus 2x squared, a minus 3x, a minus 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 to the plus, or minus minus to the plus 4x, and a plus 6. So simplifying here, I get 4 times x minus 2 cubed times x squared plus 3x to the -5th, x squared. I have 2 of them. I have actually an x squared and a minus x squared, 2x squared, so I get a minus x squared. The 3x's cancel, plus 4x plus 6. Notice it's almost the exact same answer. except that this is a negative exponent. Whereas over here, when I did it, and I seem to have lost that page. When I did it over there, it was not a negative exponent. So that's the only thing different. Oh, here it is. All right, so notice it's basically the exact same answer. It's just we had a negative exponent here instead of it being in the bottom. So I happen to like using the chain rule instead of the quotient rule. We have another one. Again, it's going to be using the product rule. I'm not going to go ahead and do that one. I think you got the idea. I want to do this one. So my outside function is e to a power, and the derivative of e to a power is e to that power, then times the derivative of the power. And the derivative of 5x squared will be 10x. My power was 5x squared. So there's my derivative of e to the power. Derivative of e to the power is e to the power times the derivative of the power. Again, same idea. We have e to a power, so e to a power, then times the derivative of the power, and the derivative of the power is e to a power, so its derivative of e to a power times the derivative of the power. So you just do e to a power times the derivative of this is e to a power times the derivative of that power. Now let's talk about the derivative of a to the x. The derivative of a to the x. Derivative of a to the x, we're going to go ahead and think of this as y equals a to the x. So that would give me, going to do that. When I go to do that, sorry, I know how to do this. I'm just trying to remember how to do it. Okay, so what we want to think about is we're going to have y equals a to the x, just like that. And so what we want to think about here is what this would actually be equal to and how to find the derivative of this. So what we have is all right, so the derivative of this, we have this, and what we want to think about is that this is, I'm actually going to do it this way. I actually don't want to do that, sorry. What I'm going to think about here is that a is e to the natural log of a. And we know that because e and natural log have the same base, and so we know that because we're composing them, e to the natural log base e, or the e to the log base e of a, is just going to be a. A to the x, therefore, would be e to the natural log of a to the x, like this. And again, remember what that means is we multiply these exponents, okay? So what we have is, we now have that this is e to the x times natural log of a. So then when we go to do the derivative of this, of a to the x, that's going to be the derivative of e to the x natural log of a. And that's going to be, the derivative of e to a power is e to a power times the derivative of the power. And the derivative of x times natural log of a. Natural log of a is just a constant. So the derivative of x times natural log of a is just the natural log of a. It'd be kind of like having 3x. The derivative of 3x is just 3. So the derivative of x natural log of a is just natural log of a. And then again, remember e to the x natural log of a, we already determined was a to the x. So we get that the derivative with respect to x of a to the x is a to the x times the natural log of a. All right, a little bit more. Let's do a couple more problems of derivatives. So we can use that rule we just did. This again, using the chain rule, the derivative of the outside function is the derivative cosine is negative sine, evaluate the inside. But then I notice I have an inside function. My inside function is a composition. So the derivative of sine is cosine. And then again, I have a composition, or actually I don't have a composition, but I have to do the derivative of the inside, and the derivative of the inside we just turned out is 2 to the x natural log of 2. So there's my derivative. And again, you're just chaining them together. So think of it as this is the derivative of the outside, evaluate whatever's in there. Then the derivative of this is right here. The derivative of sine is cosine, evaluate at the inside, and then the derivative of this is right there. So it's kind of a chaining them together. The last thing I just want to mention is parametric curves. Parametric curves are when we have x equals to a function of t and y equals to a different function t. And we can talk about the tangents to those curves. The derivative of y with respect to t is the derivative of y with respect to x times dx dt. And we know that because it's the chain rule. So dy dt is dy dx, dx dt. And notice the dx would basically, you can think of them as canceling, and you get dy dt. We don't want to do that. But if I want to solve for dy dx, because I need to know the slope of the tangents, and the slope of the tangents is the derivative of y with respect to x, then I want to solve for dy dx, and that would just be dy dt over dx dt. And this is the slope of your tangent, provided, of course, dx dt is not 0. So show that the curves with parametric equations x equals sine t and y equals sine of t has 2 tangent lines at the origin, and then find their equations. So I need to know dy dx, and again, we just proved that that's dy dt over dx dt. So you're going to take the derivative of your y function with respect to t. The derivative of y, that's a chain rule because I've got the sign of something. So anytime I say the word of, that tells me it's a chain rule. So the derivative of the outside is cosine of whatever. And then the derivative of the inside of that is the derivative of t is 1, and the derivative of sine of t is cosine t. And then that'll be over the derivative of x. The derivative of x sine of t is cosine t. So there is what that is. I know I have to have 2 lines at the origin, is what it says. So the origin is when x is 0, y is 0. So 0, 0 is my origin. X is equal to sine of t. Y is equal to sine of t plus sine t. I want to know when x is 0, we have sine of t. When y is 0, we have sine of t plus sine of t. So I need to find out what those t values are. Well, this one, sine of t is 0. That happens when t is 0. But if t is 0, we get 0 here. So where else does it occur? What also occurs when t is pi? Let's see if that works. If I put pi in here, the sine of pi is 0. And then I've got pi plus 0, which is pi, and the sine of pi is 0. So we also get that same answer. So there actually are 2 values where this occurs. There's actually a lot more because there's also 2 pi and so forth, but 0 and pi are the ones we want. If I go back up here, I didn't give you any kind of things. Okay, good. So those are the 2 different times that I have, and then I can find the equations of those. So one equation would be remember, it's y minus y1 is equal to the derivative dy of t, dy dt, dy dx, sorry, times x minus one of the x's. And dx dt, we just found out, was cosine of t sine of t plus times 1 plus cosine t over cosine t. We are at 0, 0, time t is 0. When we do that one, dy dx would be 0 plus 0, which is 0. So the cosine of 0 is 1. And then we have y plus the cosine of 0, which is 1. So we have 0 times 1 times 2. So we do still get the cosine of 0, which is 1 over 1. And then we also have the pi in there. So when we have the pi in there, we're going to get dy dx is pi plus sine of pi. Sine of pi is 0. So we have pi. So cosine of pi. Cosine of pi is -1. And then 1 plus the cosine of pi, that's 1 plus 1 is 1 plus the -1 is 0. So we're going to get times 0 over -1. So we get 0. So we actually get two different slopes. We get one slope of 1 and one slope of 0. So we're going to have, let's do the 1 first. So that gives me y equals x. And the other one would be y minus 0 is equal to 0 times x minus 0 is y equals 0. So there's your two different lines that occur that.